if you had not joined the room, of course. But after you join the room, click the start the attack box button up here. And once that starts, hit the deploy machine. And if you are there and ready to go, thumbs up. So we can move on. Ooh, it's a lot. Interesting. That's cool. All right. While we're waiting on those screens and everything, and our tech box to spin up, it's going to take about a minute or two. Um, if we just scroll down and we look at this, all these overflows, I guess I'm guessing these are steps. From what I went through them earlier, they look to be steps of how to overflow. Uh, and well, what this room does, I was trying to go through it beforehand, but I figured we should go through it together, just in case we all run into any problems. We can solve these problems as a team. But what this room has seemed to have done is broken each step down into pass or fail steps where we can track under the task. And that's sort of that way is probably the best way to learn buffer overflows. Uh, but if you don't know what a buffer overflow is, I would definitely do another Google search on that one. But what a buffer overflow essentially is a piece of code that has something like if you would visually think of this, it's a bucket that you can fill with. And in this piece of code, visually, metaphorically speaking, this bucket has only a set amount that it can hold, which is the word buffer comes from. Buffer comes from. And so if we continue to, say, for instance, pour water into this bucket, right? Um, it only holds a certain amount of water. So if we say put 100 gallons into this bucket that only can hold 30, the remaining gallons of after the 30, the remaining gallons are going to overflow. And that's pretty much what essentially a buffer overflow is in layman's terms. And so if you have that somewhere in code, um, what happens is you go into other memory space of that particular code. And so if you run out of that space of that buffer that code has defined, you're able to do whatever you want to do because you're pretty much in no man's land, metaphorically speaking. If that is not clear, please let me know now, because that is essentially what we are about to go through with this buffer overflow prep, and that is crucial to get I guess, a bird's eye view of what I just spoke on what a buffer overflow is visually. If that is not clear, let me know, and I can try to break it down a little bit more.
So once our machine start up, you said press deploy machine,
Correct.
and then it comes up attack box or open VPN.
Right. Do the attack box.
Okay, thank you.
Awesome stuff. Awesome. 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 Exit that. All right, guys. Once that spins up, what are we gonna do? Well, essentially, we're going to go through this task one. This task one says we have a virtual Windows 7 32-bit Windows box. And on our attack box, we are going to run this not free, X-free remote desktop software. And that's pretty much going to give us remote access to this Windows 7 box. And so if we go to our attack box and we type that in, into our terminal, we're essentially going to get something that looks like this. Let me refresh that page. Dun, 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 dun. Bam, it's awesome. It's awesome. So yeah, you might get the question, do you trust this cert or whatever? Click yes. That's from fine and dandy. This is an attack box. So it's pretty much saying, hey, I want to put this certification on your box. Is it okay with it? hit yes on that one. And once that pops up, once you have this code running, this uh, remote desktop running, you're going to get a box that looks something like this. And this is, you have essentially remote desktop into the virtual machine, the Windows virtual machine. If we are all here, let me know. If you're not, let me know.
1 second.
Not a problem. Not a problem. What's the desktop show? Alrighty. Once that pops up, we're going to check out some of these.
We're just pasting that command into the terminal, right?
Right. So I guess I should tell you. So once you're on this, the way to get the copy text over to your attack box, right? There is a little arrow, little box on your left side. You click that little arrow, push it out, and then go inside it and click the middle button where is the clipboard, and that's where your text is going to be. If you just copy or paste or either or into that little clipboard box, once you paste it into that white box, you are able to paste that same command inside of your attack box. And then that should get you started on your remote desktop. Awesome sauce. Awesome. Were you able to get it? Were you able to see your remote desktop?
Yeah, I got it.
All right, cool beans. This one real. Cool beans. All right, so now we're there, right? So we're just following the instructions and now this task 1. My next just would be, hey, we already started this. We got this first question done today, so you're going to hit complete. And our next question, or our next task, shall be running our immunity debugger. And what an immunity debugger is, it's going to take a piece of software that you give it, this exe file in this case, and it's going to break it down into registers and memory spaces and all. Pretty much, it's going to break down the exe file into different pieces of software that you can view. And the most important part, so let's go ahead and start so I can show you guys. So right click on the immunity debugger and then select the admin, run as administrator. And we're looking for, we're going to run this OSCP exe file. So how do we do that? So we go to this file button at the very top, select open. There you go. Select open. And I believe if I remember right, you're not going to see this. So what we should do is go ahead and go all the way back to our desktop. If you can find the desktop. And then on that desktop, there's this folder called Vulnerable Apps. You click inside of there. And then there is this folder called OSCP. Click that, and your OSCP exe file shall be there. Double click that, and it's going to bring up a screen that looks similar to mine. And what this screen is, what these 4 screens are, is you have your registry, your main thread, pretty much your registry code here, and these are your individual registries on your right side. If you can see my marker, and at the very bottom left, this is your hex dump of all the memory space, memories and strings that are inside of that exe file.
How did you get there again?
How did I get to the showing the registries?
Yeah.
Registries. Alrighty.
No, how did you get from file? Right.
Let me see. Let me put these on. Hold on one second, because I can't hear. All right, can you hear me? All right, you're asking how to get to this exe file right here? Okay, so if you click the file open, and let's see if I can remember how far to go back. All right, let's start from this. So if you click file open and then you drop that menu down all the way to C, local C. And if you go to users, admin, and then desktop right here, desktop, and then vulnerable apps. Are you that far? Did that get you to the OSCP folder?
Yeah.
All right, cool beans. Oh no, I just don't do that. All right, awesome. We are there. We are running. So once you have that running, right, you'll see at the very bottom it says pause in yellow and red. That because we have not actually started the exe file. So if you click this triangle right in the top under plugins, the red triangle, you click that, and it's going to run your exe file. It's going to run your binary. And then at the very bottom, you'll see you see the little red and blue and green little icon. Next to that, you'll have your console output. And that means that your program is actually running. So what else is it asking us to do? Once we're there, are we all there? Do we have a running OSCP? Yep. All right, cool beans. Awesome. Sounds good. All right. Since we are there now, and we have we want to interact with this piece of software right now. So let's go ahead and do that. So we all know what NC is. If you don't, that is netcat, and we're going to connect to our IP address. Yours might be a little different than mine, but the port should still be the same. Again, we're going to copy this command over. The way we copy again, little triangle box, clipboard, paste it, and then we should netcat that all the way to our terminal. And now we have connection from our from our attack box to our VM, to our virtual VM. And you can go through and play with it, play with some of the commands and see what you can get out of it. That's pretty much the extent of this software so far. Are we in a good position to keep going? Yes, maybe so. Alrighty. The reason I keep stopping, to make sure everybody's on the same page is because the way they have done this buffer overflow task or CTF per se, it's moving at a fast pace, but yet it's scattered all over the place. If that makes sense, it's moving fast but scattered. I don't know if that makes sense or not. So I want to make sure that we're all on the same page before I keep pushing forward. Alrighty, cool beans. So we've already done this.
I'm watching at this point because it is moving fast, man. I'm just gonna be honest with you, and I'm gonna have.
No.
I'm just
That's
gonna
fine. No, that's fine. That's fine because if we're taking this OSCP and all or any of this, if we're trying to go into this pen testing side or ethical hacking, we still have to understand this completely. So if I'm moving too fast, that's fine with me because there's going to be a lot of tasks, and this is going to be more than just one night or 1 hour. As you can see, we have over 10 of these steps or tasks, and each of these steps are a plethora of little subtasks to do. So where are you at so I can get you on the same page?
Bro, I'm gonna be honest with you. I just kind of sat back after I got into my into the what you call it? What is this?
The immunity debugger.
Yeah, the immunity debugger. I downloaded. I started that, and then that came up, and I pressed on the immunity debugger setup, and got that going. And after that, it's kind of where I'm like, okay, he's moving kind of quick. Let me just pay attention to what he's talking about, and then later on, I can follow this. But yeah, that's where I'm at.
I got you. Okay, I got you. I understood. I understand. Yeah, that's fine. That's fine. I'm going to throw a different buffer overflow that's a little more, I say, a tad bit more beginner friendly. I'll throw that in the chat room, and then you guys can go over that as well. And reach out if you have any questions on this one. But that one should explain to the very bare bones what a buffer overflow is and how to exploit that.
All right.
Cool beans. Alrighty. So for us who have already netcatted to our virtual machine box, our Windows 7 box, and we have our output that we can interact with the software. Fine and dandy. Awesome sauce. All right. So if we continue down the roadmap, we're going to configure our Mona. And there's an excellent piece of write-up on this, what Mona actually is. And it's pretty much just the interaction from the immunity debugger Python plugin, so you can interact with Mona and DLL files, and it's pretty awesome. I can pass that in the chat box as well. But that being said, we're going to copy this. We're going to set our directory for Mona in our immunity debugger. So again, we're going to copy this piece of text here, copy that over, and at this point, since we're on a different virtual machine through a VPN, we will not be able to copy from our attack box to our virtual machine. So at this point, we're going to have to type all that stuff out. With that being said, I'm going to type it out. I'm not that fast of a typer. Fid tag set working folder C:\\\. Backslash, oh, that's the wrong code. And, backslash and %p. And what this is doing is telling Mona pretty much, as the text says, our working directory. I think I just changed that too. Yeah, I surely did. Oh man, that's gonna be fun. Anyway, yeah, so it's pretty much changing our directory, setting a working folder. That's pretty much it. All right. All right. If we push on, we have our next. We're going to create a fuzzing file. And what fuzzing is, if you don't know what fuzzing is, it's pretty much sending random data, random characters to a piece of software to see if we can get a crash or some kind of reaction where it's a crash or a error message or anything that shows that, hey, we have affected this and we have affected this piece of software in some such shape or way or form. And so pretty much the easier way to do this, instead of writing this all out by hand, we're going to copy all of this. Just copy every single thing. And then again, same thing as copying clipboard. I've already done this, so mine's is there, but you should do it too. Once you get there, I think I didn't copy it. Okay. Paste it. There we go. And we can kill our netcat session. And the best way I know how, if you know Nano, that's fine, but I use Vim a lot, and it's for me it's going to be Vim. And they said name the Python file fuzzer. Name it Python fuzzer. And we should have a script with the name fuzzer ready to go. And what this script is doing, it's using the socket library's timing system, but the most important one here is the socket library from the Python API source. We're setting our IP, our port. Again, your IP should be different. but port should stay the same. And this is that buffer I was talking about. This is that buffer. This is right now, this is the buffer that we are sending, we are setting, but pretty soon we're going to try to break the buffer that this OSCP exe file is. This is just our counter. Again, we're putting those this lint into this buffer or whatever, filling the buffer with how many A's. And this is the important part. So after we set the buffer up and everything, we're going to create a connection, a socket connection, right? And this socket.af.net is just the IP family. If you don't know about sockets, I would definitely try to Google socket programming or Python sockets API, and it should give you a good understanding of that. Again, this is the type of socket. This is the family of sockets. And here is how we're going to connect. This is the connection IP port combo. And we're telling it to, I'll comment this one out. Let me do that right now. I was playing around with this earlier. Nope, that's not right. Awesome. All right. And so we're telling it to whatever data you get back, I want you only to send me 1024 bytes of this data, of that data that I get. We're going to print it out, and we're sending the overflow. And if you remember, when we typed help on our netcat sessioning in it to connect to the OSCP exe file, one of the commands was overflow and then whatever. This space right here is very important, because this is how I'm guessing it eliminates from the software command to whatever command we pass it. You know what? Let's just do it this way. I did it twice. Fine, I just do it this way. I forgot what it was. Anyway, and then we're closing connection and then printing out that if we couldn't try accept, if we have an exception on connection. So if we keep that, right, the way we will run this is go back to our file, our try happy. You run it with Python. Python is awesome. Python is amazing. I can barely hear you. I can't hear you.
Can you hear me now?
Yep.
How do you exit Vim again? I know it's something W2.
You're gonna hit the escape button on the Windows box is ESC. You hit that, and then it's gonna be Shift, and then the 2 dots, the colon.
Thank you.
Oh, that's not right. Make sure I got it right. Cool beans. Where was I at? Running the file. There we go. Yep. So it'll be Python. Let's exit that out first. Fuzzer. There we go. Python fuzzer. And you should see something of this saying that we sent 100 bytes. I think that's wrong. And on our software, we can exit this log if this did pop up for you. You can just hit the exit. That's not really that important. But over on our software, we can see that we made a connection. If we have this, if we did everything right, you should see a connection from our attack box to our OSCP exe file, to our Win7 box. Awesome sauce. Awesome sauce. And this is just confirming that our fuzzer script is actually connecting. That's all that pretty much is doing. Alrighty, so let's see if we can interact with this. Increasingly long string. Fuzzer will send increasingly long strings comprised of A's up to 3,000 A's. Fuzzer crashes the server with one of the strings. You should see an error like cannot connect to whatever IP port. Make note of the largest byte sent. So with that being said, I don't think I saw that. Let me make sure. This is very. Yes, we have a connection. We're receiving. We have buffer pin. We're appending however amounts we have. What is our counter? It's 100. Oh, that's fine. And then we start at 100, and then we continue with this. Buffer's less than 30. And then we print. All right, I'll just keep going. I'll see what they're doing. Anyway, so yeah, let's see if we can crash it with controlling our EIP. Our EIP is our extended instruction pointer, I believe that's what it stands for. And if we were to go back and look at the immunity debugger, let's go back. And on our right side, these registers here, these register is the EIP. The EIP is one of the main important ones. This tells you what instructions in that piece of software. It says the instruction pointer tells which instruction or which set of code to run within the next file after a previous command has already ran. So we're running, the instruction pointer is pointing pointing to our next command to run, and then that's what the EIP does. If that is confusing, let me know, because it took a while for me to understand that too. But pretty much, if you're doing buffer overflows or exploit development, EIP is your main source of attack. And you're trying to attack this because it controls the program structure. And so right now, our EIP is this strange little value. You don't know what this value is, but it seems like it's pointing to a Windows DLL file. Aha, it's pointing to this address space right here. So yeah, it looks like it's a Windows DLL file. So we're gonna try to control this EIP, right? And so with that being said, again, we're gonna try to do this instead of trying to write it out by hand, we're gonna write it out, copy and paste. So we bring that from our Try Hack Me website over to our attack box. Control P. Bam, sis. I've already done this. And so I'm gonna name it, and we should name it exploit py. I'll make sure. Yep, exploit py. All right, cool beans. So after we bring that over, we hit vim, make sure we're in the same different file on this one, and we paste that inside of our exploit py file. Right? Ignore the payload for now. That is something that I was playing around with myself. Actually, I just delete that right now. Awesome. Cool beans. All I'm doing is just fixing the script, which is I can type right. Awesome. All right, cool. So once we have that, we have our script running. We have our script copied and pasted over. We can see if it runs. So our IP and port should all still be the same. It's the prefix. This is the command that we're going to send over the buffer, the overflow one. If you remember from our fuzzer, we sent this as well. But this is the prefix. This is the command that we saw. This is the offset. The offset is pretty much what it sounds like, offset. We're not sending any times 0. Anyway, offset, and then we are connected. So let's see if this works as well. And it's going to be Python again. I believe it was exploit. Awesome. If you are everything is set forth in A-OK, you should see the evil buffer sent. You won't see any interaction on the OSCP exe file because we have not really sent over anything in the script itself. Yeah, we have not really sent over anything because this offset is times 8. So we're sending 0, pretty much A's, no A's at all. So that's fine. So now that we have this is just the beginning portions of our exploit script. And that's all that we're doing. We're setting up our actual exploit that we're going to use to control that box. So our next one is to see if we can create a specific pattern to control that EIP register that I spoke of earlier. And the easier way to do this is using exactly what this is, this Metasploit pattern create, this Ruby file. And I believe that if you copy that command over to your attack box, it's not working. I don't think it's in the right folder, because I did it and I couldn't find that folder. It's not in that folder that they're pointing to. So I believe it's in your opt file. Come on, you can do it. There we go. Alrighty, and so if you type opt, well, /opt Metasploit framework, all that you see here, and then tools, exploits, and pattern create. And what this tech L is telling you how many, I guess, bytes that you want to create, or length of a pattern that you want. And we are using 600. The reason why we're using 600 because that's what the instruction said. The instruction said use 600. I hope that is good. Are we okay with creating this pattern? Is anybody lost that is wanting to follow? Everybody good? Yep. All right, I'm gonna have reading complaints. All right, cool. And so what we're doing with this payload, we're pretty much just gonna payload. That's this pattern. It says it's here, right here. We're gonna copy out this. Yeah. We're going to copy that pattern that we just created and put it in our exploit file. And then see if we can find where this, actually, let's go back. So we're going to create this, we're going to copy this pattern of 600 bytes, this unique pattern of 600 bytes, right? We're going to put it in our exploit script. So we go vim exploits and nano exploits, whichever your favorite text editor is. And we're going to paste that in our payload. I believe that's what we said. Put that. Paste this in the payload variable. All right, cool. And this is Python. If you try to copy that script, that pattern in this right now, you might get an error, right? Let's go back. Don't do that. There we go. Input. And the reason that you're going to get an error because Python is very sensitive on how its multi-line comments are. And if you don't know what I mean, I can show you right now. And that's exactly what I mean. It's going to give you a syntax error and all that good stuff because of Python uses multi-line comments on this session, or on this point. And the way you do that is, the way you set a multi-line comment in Python is the 3 single quotes. If I can get my cursor there. There you go. 3 single quotes, 1, 2, and 3. Delete that 1, 2, and 3. And that should give you your full payload that you want to send over to the OSCP. All right, let's see if that works this time. Yeah, that's right. Awesome sauce. Awesome, awesome, awesome. Did we interact with it? Probably not. Let's try it again. Yep, there you go. Make sure it's all right. And so at this point, we should have saw that our script, our payload that we sent over was sent over and affected, and we got a connection open and closed. And let's see if we can actually just follow the instructions. All right, so after we send that, after we execute our script, we should be able to find our pattern. And this is what the IMONA find MSP distance of 600 is. So let's copy that. The script again should crash. LCP immediately debugger. Run the following one command. Change the distance in the same length we had in great. Monitor display log windows, blah, 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 blah. All right, cool. So after we, let's copy and paste this command over, this Mona command, right? This Mona command here. Copy it from our attack box to our attack box. Oh, look at that. And, oh crap, yeah. leave it open. So this command is going to be inputted in our immunity debugger. And at the very bottom in this white space, you should have a text field where you're able to type that command. So let's type it in. Tech Mona, find MSP, tech distance. Come on, you can do it. There you go. Distance of 600. Dun, 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 dun. And what this is doing is pretty much looking in the memory space of for that pattern that we just sent in the EIP register. It's going to give you a offset, not an offset, but a number where exactly that pattern starts in the memory space of that OSCP exe file, if that makes sense. And so what are we looking for in this portion? Mona should display a log window output. If not, click the Windows log data to view the CPU standard. In this output, you should see something that says EIP contains normal pattern of this offset. So let's find it. I don't see it. I don't see this anywhere. Does anybody see this? I see that command. What is this? Examining 600 bytes for the exam. 4B4 bytes. Walking stack from 0 to examining 600 bytes. Pattern. Adult syllabus. It's rock and roll. You didn't get my right output. Interesting. All right, let's go ahead and close that out. Let's see what our ERP says. Still the same data that I'm running. We are running. And see. Over. Not paused. Interesting. Pattern. Dot. And we are trying to look for this offset where this turn distance is. Interesting. Well, we probably don't need it. Anyway, since that can give us what we're wanting, let's move on. Let's keep moving, pushing forward. We'll figure that pattern out later. I think that's important for this. Anyway, so I'm not seeing that. Type it wrong. Mona, find MSP, distance of 600. Interesting. Wrong button. Examine this thing. Follow the instructions, and it's still wrong. Cool beans, whatever. We don't need it. Let's move on. We'll come back to that if we need it. It's not hard. It's not that hard. All right, so we can update our script with this BBB 4242 hex decimal. And so what it says is update the exploit script, set the offset variable to this value, okay? Previously set to 0. That might be important. Set the payload value variable to a few the B's, the character 4 B's, and set their return value again. Restart the OCP, and we should see 424242 in our EIP variable. Register. Interesting. Did I miss a step? All right, let's play around with this script, and since that's not giving us what we want. So what it says is, go here. And offset is going to be. I'm telling this script is telling us to offset of blah, blah, blah. How many A's do we want? And our payload is going to be what we want to send over. So this. Okay. Interesting. What I'm doing now, I'm just trying to troubleshoot this, see exactly what's going on with this script, what was provided to us. And sometimes you have to do this with exploit development. You definitely have to do this on the OSCP exam. Um, so pretty much what I'm trying to do is figure out what this exploit offset variable, and then variable to value set the payload variable to string, set the return variable to. Interesting. All right, let's see if we can do it that way. See if we ever just put a number of. Let's go 2000. Fine. See 2008. Let's go 4,000. Make it bigger. Let's see if we can see that. And then here we're sending our buffer of the prefix is overflow plus overflow of 4,000 A's. And then our return value is still set as nothing. Let's see if we can add that too. And then our padding, we come to that later. And then our payload, this is going to be our shell code here. And then we send, let's see if that works, guys. Exit that out. We don't need that. What is our EIP right now? Our EIP is that one. All right. And let's see if we can send this exploit over. Don't have. It already crashed? I think it crashed. All right, let's try this again. Let's close that program out. I don't know what's going on with this. Exit that. We don't need that going on. Nope. I don't want to restart. Right now, I'm just restarting the program. That's fine. So let's go back. Let's just go here. Come on. Bounces. OSCP again. It's paused. F9 and then run. And let's move this down here. EIP is the same thing as that. And we have liftoff. You see that? We send our buffer. Actually, what? But I don't see where my script is at. All right, fine. So we're sending over. Print sending this buffer. Even buffer. Let's see what it's sending over. Awesome. So we're sending everything up there. All right, so we're sending the crap. We're sending it over, but we're not getting any interaction. What am I missing? All right, well, let's increase it. I don't think it should be that big of a buffer. Oh, I'm not in Vim. All right, 40,000 A's. Am I missing anything? Back to 8,000 A's. All right, cool bean. And we're sending 8,000 A's plus this. This doesn't matter right now. We are just trying to get a crash. We are trying to get a crash. Interesting. Interesting. Okay. All right. Well, let's see what happens if I do it this way. what happens if I do it this way? Copy. Let's search that again. Cut that out. And we'll exit this and we paste that. We send that over. Well, we got a crash that time. That means we're not. So I'm guessing somewhere our script is jacked up. And that being said, so our payload works. Pretty much what I just did is I interacted with the software itself. I did one of the commands here, and I sent over, though, I guess it was like 8,000 A's just to see if we can actually get a crash, which we did. We got a crash. That's where it says pause here, and it's highlighted yellow and all that good stuff. But the most important thing of this is if we see our EIP is 41, 41, 41. And if you know ASCII characters, that's going to be this long string of A's. It's going to be 4 A's. And so with that being said, we are able to control this EIP register, or this send this buffer and control the EIP on this piece of software. Normally what the next step will be is to see exactly where this crash is happening, how many bytes that we need to send to get this, to control this EIP register. And that's where the pattern of 600 bytes came into play. But as you just saw, that the script was not working correctly. So, what time is it? Okay, 4 minutes. ASCII characters of ASCII. So with that being said, let's see if we can freaking figure out what's going on with this script. Because that is the script that Try Hacking gave me. If you find a bug in Try Hacking, we get free access. Let's see. Alrighty, we are sending 8,000 bytes. Actually, you know what? Let me see something. Let's go back. Let's go back to this one. Go back to our fuzzer. And if we are sending this buffer. Where are you at? I'm gonna let them right here. So we are sending buffer overflow. For 1 plus strings. Alright, and string is something that I don't need. Let's see if I can comment this out. Make this out. And then that's fine, that's fine. That's what I'm looking for. We can say, this is gonna be too much. We need the editor. We need the actual editor. Let's see if this works now. Yeah, we need the actual editor. It's fine. I don't feel like doing that right now. Let's go back to our exports. So we are sending it over, and then we have our buffer, our prefix. What is our prefix? Nothing. That's our sending buffer. Buffer is this. Buffer is. Oh, dang it. Okay, let's comment that out. Let's see if we can. Send it this way. Buffer. Overflow. Buffer equals overflow 2008. That should be fine. So restart this. I don't need you. Cancel this out. Yeah, I set that to yes. Restart our OSCP. And then we can send our buffer. I'm gonna exploit again. Huh. And yet we get nothing. Awesome. So this is very unfortunate. This is very unfortunate. Cool beans. As I stated before, this is very incremental steps right here, and as you see, we ran into an issue with this. That's very unfortunate because I was thinking that we can get past this, and we are running out of time. Awesome. But with that being said, we have hit our hour mark. I'm going to continue to work this. If you want to continue to work this, that's fine. I actually want to see what's going on with this script. But again, I have other buffer overflow programs and examples and things to play around with. I'm definitely going to send that out into the chat room. But again, I'm gonna stick around and play with this and see what's going on with this script. Feel free to, if you want to, again, try it yourself. Go for it. But until next time, happy hacking, and apologies for not actually getting this script to work. But we will resume this next week, next Friday, and I will have a working exploit for that one. I will have a working exploit on this one. Again, yep, sorry about that. Are there any questions? What is wrong with this script? That's not a script. Have I been talking to myself? Anybody there in the cyberspace world? Hello?
I was still here. I was waiting for you to put that because nobody said anything.
Alrighty, cool. Well, again, that's the hour. If you guys want to stick around, feel free to stick around. But I am going to try to fix this dang script because I really want to know what's wrong with it. But again, that's the hour. I will have a working exploit next week for this because I want to continue this buffer overflow because I think it's very, very helpful. It's worth 25 points if you're taking that OSCP exam, with one of the highest boxes out there. And it's actually not that hard if you think about it. Buffer overflows are not that hard. What's hard is actually finding what's a little complicated is finding the bad characters and the memory space to interact with, and the piece of shell code that you should. Say again?
Do you think that is not working because the exploit Python file, the script file has some errors in the code or what?
Yeah, feel free. Do you want to? Are you saying you want to share your screen or something? Because I missed that last part.
No, I'm just asking. Is there any problem with the code itself? Sometimes.
Oh, let me actually see. Let me see. I think it's something. How this script is being. Let me see. Oh, there we go. How the script itself is being sent over. Because if you remember, we did interact with it by itself. What I mean by that is I was able to. Am I frozen? No, there we go.
Because this time he asked to set the payload variable to the string of bad characters. So
yeah.
The same old payload. So do you think that we need to make the change to the payload itself? I don't know.
Oh, yeah, we can change that. But if you see here at the very, like this one right here, this is the overflow itself. With it's just pretty much sending just blank characters over. But yeah, we can try that out. Let's see. Because I just caught something that I messed up on myself. Let's comment that out, and then we should also comment this out. We don't need that. And if we see, so we actually need our prefix before this too. Oh, Jesus, prefix. And so we can actually print this buffer. Oh, we already printed it out, yeah. Printed it out already.
Yeah, print buffer is already there, yeah.
And let's see if that's, see if we get that one from there. Python exploit, and we are running. Awesome. There you go. I saw that too. It's telling me that I did it. Let's find out what did I print at the beginning? Yep. Yep, that's exactly it. You saw it. Overflow. Yeah. Interesting. Let's see. Why am I not getting that connection? Okay. Why am I not getting sync over? What is sync missing? Let me stop it. Just one more time. There we go. And if I go to Netcat, that's right there over. Put that in. And I'm sending that exactly what I want to send. Overflow, blah, 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 right? Okay. And that works. If I use the script, it jacks up. Anyway, let's see. Alrighty. We start this.
My machine time is expiring.
Ah! I think I'm about to hit that limit myself, actually. Let me see. Where you go? Oh, 30 minutes. All right, cool. 30 minutes left. I'll piece that. All right, let's see. Let's go back. What is? I don't want it. You can keep it. You want to put a nice one? Thanks. This is my IP, right? That is the IP. I just saw it connected. So
Yeah,
1.2777.
That's correct.
Okay. Oh, this is the prefix buffer. Alrighty. Let's print the socket. I should have a Jesus. Print. That should be an address. And it tells me that I have a socket connection. And then I get this part right here. I get this right here. Do I need an extra? Turn. Back RN. That's right. Return characters, return new line, return new line. Okay. And my buffer. Let's try this out. Am I running? I am running. Yeah. Let's try. What is wrong with this, man? Tell me I'm wrong. Telling me I'm wrong. I have a socket. Yep, that is right. I have my socket in there. Yeah, that doesn't matter. It's just saying this. I have my address and everything, and I have my command. Man, what is going on with this? This one. Yeah, I'll figure this out later.
Okay.
I'll figure this out later. I would definitely come back to this because this is gonna bug me now for the night. Yeah, I like I said, I'll send a better one because I don't like how they just did these steps in this one, but I guess it's helpful for people. But there's a better one out there, and I can send that to the group chat.
Sure.
That actually helps. It has videos and all. All right, cool. I appreciate y'all coming through. Until next time, we have something next week.
Sure. Thanks a lot.
All righty.
Bye. Good night.
Bye-bye. Good night. Good evening. Good night. Good morning. What is going on with this?
Did you say something, Josh?
No, I'm just trying to figure out what's wrong with this script.
Oh.
No, I didn't say anything. No.
Okay.
We're done.
Are you okay with me ending the chat?
Oh, yeah, that's fine.